What's good, gamers? What it do? It's your boy J-Bo, aka the Old Man Gaming Guru, bringing you a little something you can use for your toolbox this morning, evening, or afternoon, depending on where you at. But yo, we about to get into this Mark Cerny, SIE headquarter TED Talk is what I'm calling it. But more so, it was a shots fired jamboree. But yeah, he put everybody that was assuming what they knew about the PS5 Pro before it launched on notice. He put Digital Foundry on notice, pretty much allowing them or letting them know that they tools don't no more. They outdated and they don't apply to the Pro. So let's get into this and see exactly what Mr. Cerny had to say.
Recently, there have also been console releases during a generation, like PS4 Pro and now PS5 Pro. These are much more tightly focused, typically on the GPU. And what developers are making are improved versions of games, never dedicated games. So targets for Pro consoles are very different. First, the work that needs to be done by the game creators for the Pro console needs to be kept to an absolute minimum. They already have a lot of pieces of hardware they're supporting. We don't want to add much to that burden. And second, those tightly focused improvements need to be pretty significant. The games have to play noticeably better.
As you heard him say, the games need to play noticeably better. Putting development teams and development houses on notice that most likely PlayStation is not about to go for the half-assed PSSR implementation we've been seeing from many of these studios. But, I'll let him finish telling you exactly what it is.
AMD is continuously updating the GPU technology. RDNA 3 has more functionality and is more performant than RDNA 2. There's even a chance to bring in future RDNA technologies like we did with ray tracing. If we're making a new generation of console, of course we want the latest and greatest. But with a mid-generation release like PS5 Pro, we also have to consider that a single game package needs to support both PS5 and PS5 Pro. That limited the degree to which we could adopt RDNA 3 technologies. For example, games have something called shader programs that execute on the GPU. A game might have over 100,000 of them. If we adopted RDNA 3 technologies to the extent that code compiled to run on PS5 Pro wouldn't run on PS5, that would mean creating two versions of each executable piece of code. One for PS5, another for PS5 Pro. That's a massive complication. The game package needs to be patched to include that second version, and then the game needs to either selectively load just the appropriate version or find room for both versions in system memory. It's a big burden for the developers. Consequently, PS5 Pro uses a version of RDNA that I'm calling RDNA 2.x, which is bringing in a number of features from RDNA 3, but not anything that would cause that degree of complications. For example, aspects of vertex and primitive processing are faster on PS5 Pro. That's from bringing in parts of the geometry pipe from RDNA 3 that are powerful, but either trivial for the game to adopt, or better yet, invisible to the game program. One thing I'd like to clear up is the erroneous 33.5 teraflop number that's been circulating for PS5 Pro. That number isn't anywhere in our developer docs. It comes from a misunderstanding by someone commenting on leaked PS5 Pro technical information. Part of the confusion comes from RDNA 3 architectures having double the flops of RDNA 2 architectures. Now, to quote Digital Foundry on this topic, it's a nice little bonus to have twice the flops, but it doesn't do anything like double real-world performance. So there's a certain amount of flopflation going on here. We did not bring in the doubled floating point math from RDNA 3 because achieving that bonus in performance would require a recompile for PS5 Pro. And as I said, having two versions of each compiled piece of code would create more work than we're comfortable asking the developers to do. Here, then, are the correct stats for PS5 Pro. It's pretty simple. PS5 Pro has 30 workgroup processors, which is 67% more than PS5 has. So the flops should be 67% higher as well. If we assume a pretty common operating frequency of 2.17 gigahertz, the math works out to 16.7 teraflops on PS5 Pro. Of course, teraflop numbers are pretty meaningless. What isn't meaningless is the performance of the PS5 Pro GPU. 67% more workgroup processors means that we can create synthetic tests that show 67% faster processing. In practice, though, there are a lot of factors involved, such as memory bandwidth or even how a particular game engine responds to the details of the new architecture. So a game team might be looking for something more like a 45% increase in rendering speed. That's still a huge improvement, though. At that performance, it means that if a game is running at 60 FPS and is taking 16 milliseconds to render on PS5, then that same frame could be rendered in 11 milliseconds on PS5 Pro. That leaves 5 milliseconds to do something new and exciting, like adding ray tracing, which is the second of our 3 key improvements on PS5 Pro. There's a passion in the game development community for ray tracing. Even in 2020, before the launch of PlayStation 5, we could see creators using ray tracing to add reflections and improved lighting to their games. At the same time, calculation costs for the rays were pretty high, so when we kicked off development of PS5 Pro later that year, one of our top priorities was finding ways to accelerate that computation. Those conversations with AMD led to our very nice feature set that's showing up here first. The final improvements to the GPU are for machine learning. There are a lot of uses for machine learning, or AI, whichever term you prefer. Large language models and generative AI are quite interesting tech, but with ML, it's also possible to go after a very specific target, which is to give the games a graphical boost. One of the key ways that can work is that the game renders less. There's 8 million pixels on a 4K TV. If the game renders sparsely, say a quarter of those pixels, it can do it a lot faster. And then the right neural network can intuit how to fill in those gaps and make a high-quality image. Another way to think about this, which is not quite as accurate, is that the game renders a smaller, lower-resolution image and then uses the neural network to upscale that image. This is called super resolution, and it's part of a whole family of strategies that reduce the work involved in rendering the game images. There's also frame generation or frame extrapolation, where a neural network inserts additional frames between the ones the game renders. That can really reduce the choppiness of low frame rate games. Neural networks can also be used to turn noisy, staticky images into smooth ones, which is an issue that crops up frequently, particularly with optimized ray tracing. Having said that, super resolution is definitely the focus of our current efforts. It's important to note that high-quality upscaling changes the way we should be thinking about game rendering resolution. Let's imagine 3 games that are rendering at various resolutions. A reductionist view on this is that the 1440p game engine is the best, and that the 1080p game is clearly flawed. But after a super resolution pass, these are all ending up at 4K resolution for display. The conversation really needs to be about what's important: image quality. When game creators improve their lighting or materials, or add ray tracing, then rendering each pixel can get more expensive, and the resolution will drop. They move up on this chart. And that's perfectly fine, as long as the upscaling technology is ensuring that the result is a crisp, beautiful image and not a blurry one. A different way to say that is that high-quality super resolution lets game creators focus on fewer, richer pixels and significantly improve the resulting image quality. It's a world where internal rendering resolution is not the primary concern. That's the world we want to be in.
As you can see, Mark Cerny literally confirmed what I've been saying for months, whether it be in comment sections, friends, whether it be the tech gurus, whatever you want to call it. Those tools that Digital Foundry use do not apply to the PlayStation 5 Pro. They're outdated. This is new technology. It's its first iteration. And all that matters is what's received on the end user's experience. Image quality, smoothness of gameplay. That's it. That's all that counts. That's why I always say, where are all those comparisons? You know, the off-screen comparisons with the 4K TVs, you know, kind of like John was doing on Digital Foundry before they made him stop, because it wasn't fitting the vibe of hating PlayStation, and that's what's trending online at this time. But let's continue.
ML hardware needs very high performance, typically hundreds of trillions of operations per second. Note that we don't call those teraflops because they're integer operations. Instead, we say tops. There were a number of early decisions we had to make. The very first was deciding where in the hardware we would put whatever would do all of that matrix math. Generally speaking, there's two options. One option is to put ML capabilities into a GPU. Of course, that's additional logic so the GPU gets larger. Or one can add an NPU, a neural processing unit. NPUs are brilliant at executing neural networks, but perhaps not so good with the pre-processing and post-processing surrounding the CNNs. The deciding factor was the order of graphics processing within a frame. With this approach, most rendering in a frame is done at low resolution, maybe 1080p. Then machine learning is used to upscale to 4K, and there's no more rendering that can happen until that upscale finishes. So we need to process that neural network as quickly as possible, which is to say, we need very powerful ML hardware. The more powerful, the better. That need for power is what pushed us towards using an enhanced GPU. The choice was either adding a large NPU or making more moderate enhancements to the GPU. The next big decision was where all of this technology was going to come from. When we were starting the PS5 Pro project in 2020, we knew that we would need performant ML hardware and a high-quality neural network for super resolution. But we're not looking for ML hardware that's generically high performance. We need something that's optimal for our specific kinds of workloads. And our typical workload is a lightweight CNN, something that can run in a millisecond or so and has a lot of little layers.
Shots fired. Shots fired. Generic power. He's talking to you PC guys. He's letting you know, due to the multitude of configurations that you have, that's just generic power. It's going to behave and perform different depending on your configuration of components. That's why the PC master race was so upset about the PlayStation 5 Pro. Due to their experience with DLSS, FSR, and even XESS, they knew that the PlayStation 5 Pro was going to be a monster. And it was going to really affect the way people look at PC gaming from here on out.
By the way, the 300 TOPS number has been a real mystery since it leaked early this year. No one on the outside has been able to derive that number from the workgroup processor count and the GPU frequency. The secret is that there are instructions that perform 3x3 convolutions. Those use 9 multiplies and 9 adds for a total of 18 operations. And at that pretty common GPU frequency of 2.17 gigahertz, the performance really does work out to 300 TOPS. Here's the math. The CNNs also need 16-bit math, so there's a number of instructions for that. These instructions tend to be a bit simpler and more straightforward. We kept the chip area and the cost low for the 16-bit math simply by targeting lower 16-bit performance, because most of the processing in these CNNs can be done with 8-bit operations. As for 32-bit math, nothing in the CNNs particularly seems to need it, so we just left it as is. Our custom RDNA solution also involved a number of additional features, which I'm going to skip over so I can get to the other half of what we built, which is the neural network for super resolution that we created to run on top of that custom RDNA architecture. PSSR is an original PlayStation design. The full name, of course, is PlayStation Spectral Super Resolution, and that spectral is branding. It doesn't refer to any particular aspect of the algorithm. Just like we have Tempest for audio tech, we're using Spectral for our ML libraries for graphics. One of the project goals for PSSR is ease of adoption, so it uses essentially the same set of inputs as FSR or DLSS or XESS. Those strategies use the pixel color of the current frame, but also depth information and motion vectors that give the flow of the pixels between the previous frame and the current frame. PSSR is not quite a drop-in replacement for the other strategies, but it's close. Having said that, PSSR is designed for consoles, so its primary use case is a little different from the others. PC games tend to render at a fixed resolution and with frame rate that varies based on scene complexity. Gaming monitors can handle that variable frame rate. So a typical PC game scenario is render at fixed resolution, upscale by a fixed 2-to-1 ratio, display at fixed resolution. In contrast, console games tend to have a frame rate that's fixed because they're displaying on a 60 FPS TV. What varies is the rendering resolution. If the scene is complex, then the rendering resolution is lower. If the scene is simpler, the rendering resolution is higher. Since the display resolution is usually fixed at 4K, PSSR needs to handle a continuously changing upscaling ratio. That scenario is primarily what we design for and train for. Of course, PC games are increasingly supporting variable rendering resolution, and all of these upscaling strategies can handle fixed upscaling ratios and variable upscaling ratios. I'm just pointing out that the focus with the PSSR project has been a little bit different.
In other words, what he's saying here is the Pro is not made for a monitor. It's made for the TV that I told you guys to get a long time ago. It's made for the HDMI 2.1 120 hertz VRR ALLM solutions that have been on the market for over 6 years now. So testing the PlayStation 5 Pro on monitors, testing it on TVs that don't have these specifications is pointless. It doesn't show anyone anything. In fact, it just spreads misinformation. I guess Sony had enough of the misinformation going around and decided to double down on another tech talk to let you guys know exactly what's going on behind the scenes. I have the machine. It is a beast. The upgrade is extremely noticeable. It's damn near generational, like Oliver said when it first came out. But we all know over there at Digital Foundry, they were told by someone to calm it down and change the vibe that they had going towards the Pro.
Through PS5 Pro, we've developed some good understanding of hardware design for machine learning, as well as neural network design, and we intend to continue this work with a pinpoint focus on games. Of course, as part of their broader strategy, AMD is pursuing many of the same goals. And so I have some very exciting news to share. We have begun a deeper collaboration with AMD. For the project name, we're taking a hint from AMD's Red and PlayStation's Blue. The code name is Amethyst. With Amethyst, we've started on another long journey and are combining our expertise with two goals in mind. The first goal is a more ideal architecture for machine learning, something capable of generalized processing of neural networks, but particularly good at the lightweight CNNs needed for game graphics, and something focused around achieving that holy grail of fully fused networks. In going after this, we're combining the lessons AMD has learned from its multi-generation RDNA roadmap, and SIE has learned from the custom work in PS5 Pro. But ML use in games shouldn't and can't be restricted to graphics libraries. We're also working towards a democratization of machine learning, something accessible that allows direct work in AI and ML by game developers, both for graphics and for gameplay. Amethyst is not about proprietary technology for PlayStation. In fact, it's the exact opposite. Through this technology collaboration, we're looking to support broad work in machine learning across a variety of devices. The other goal is to develop, in parallel, a set of high-quality CNNs for game graphics. Both SIE and AMD will independently have the ability to draw from this collection of network architectures and training strategies. And these components should be key in increasing the richness of game graphics, as well as enabling more extensive use of ray tracing and path tracing. We're looking forward to keeping you posted throughout what we anticipate to be a multi-year collaboration. Let me get back to PS5 Pro for one final moment. You've now heard a bit about our fairly intense last few years building this console and developing PSSR. There's been so much learning for us as we delve into these new technologies. But the payoff, as I said in my PS5 tech video a few years back, is in the games. And by now we know to expect the unexpected. It's an absolute guarantee that the development community will grab a hold of this technology and move in a direction that we never could have anticipated. Personally, I can't wait to see what they do with it. Thank you for your time today.
Does this new partnership and project signal the end of Microsoft's next console, handheld, or whatever technological leap they're claiming that they will make within the next few years, I'm not sure. But I smell something. And where there's smoke, there's fire. Stay tuned to this one because this is going to work out very interestingly. And not only are they looking to upgrade our gaming experiences, they're going to expand this technology to other devices. He doesn't mean Xboxes. He means hospital equipment like dialysis machines and heart monitors and things in other areas and other genres that use machine learning to analyze data, to analyze projects. This is going to be very interesting when it comes out.
We've gone hands-on with PS5 Pro. We've taken a look at a number of games under the microscope, and we've talked about the PS5 Pro over hours and hours of content. But what we haven't done is sit down with some of the people who have made PS5 Pro and some of its software actually possible.
We'll bring that ass here, boy, because we finna sit down and tell you to your face how your tools are outdated. And you speaking on us wrong. You speaking on the pro wrong and spreading misinformation. Let's get to it.
I think with PSSR, a lot of people are pretty interested in a certain kind of problem, which is that you have a pretty tremendous improvement in image quality. And I think we see this across, different kinds of PC upscalers as well when we're talking about that. But the internal resolution of that imagery might not be changing that much relative to what you saw before. So are you guys kind of trying to figure out how to message that to people and tell people like this is a profoundly improved image despite the fact that the internal resolution is comparable? And I know that we're part of this problem for sure. So that's a tough thing to message. But have you thought about that?
You're not part of the problem. And I've heard you talk. I spend too much time on DF, but I've heard you talk about how you really shouldn't be looking at internal rendering resolution and drawing too much in the way of conclusions from that. You really need to be looking at image quality. And I was trying to communicate exactly the same message today, is we need to change the way we're talking about resolution. Maybe we shouldn't be talking about it at all. The difficulty is if you don't have a number, it gets very hard to have that conversation.
Yeah, I think we tried to get away from it at some point by just maybe stop telling the numbers and start using like some kind of model that would tell people what the approximate image quality is. Yeah. But it's a big challenge because like you're trying to communicate different things, and resolution is an important part of that at the moment at least, but that final image is ultimately what really matters to people. And I think that's what we're seeing with PSSR for sure.
Yeah. Called out to his face. Just like the people and the supporters of the Pro have been saying, it's about image quality and user experience. Digital Foundry has been rendered irrelevant when it comes to the PlayStation 5 Pro and what it's able to do. Reason being, they are capturing footage before it gets to the TV, which is the final step of the PlayStation 5 Pro. They intentionally curbed the enthusiasm of John and Oliver, stopped John from showing his TV because you were able to see just how much better it actually looked. And mind you, that would be on a cell phone that's not 4K. If you were on a laptop or PC and you're watching YouTube on a 4K monitor, you can clearly see these differences with no problem. So it's obvious the majority of people that were hating on the PlayStation 5 expected their phone to magically play in 4K or something. I really never figured that out. But like he said, it's not about a number. It's about what it looks like, which is why we need to see off-screen comparisons. I would love to see a 4090 versus a PS5 Pro on the same monitor, but two separate monitors, but the same model and brand. A high-quality video, 4K, at least 60. They got 4K 120 cameras, and judging by Digital Foundry's footage, they got the cameras to do this. That would then give everybody a true indication or a true representation of what the Pro actually does in real life. But for some reason, no one will do that. Only half-captured, half-assed comparisons is what you'll find on the Pro. And I really don't understand the enthusiasm is stopping people from enjoying the best gaming experience that they can afford. Everyone can't afford $1,800, $2,500, $3,500 plus for a PC that barely outperforms the Pro. And that's the problem. And that's why I received so much hate pre-launch, and that's why it's even received even more hate after launch. People are butthurt. There's no other way to put it, man.
But did you have a certain kind of game experience in mind to deliver to players when you were designing this console? Or was it like, we're going to achieve big power improvements and then the developers are going to show players what that looks like?
It's a mid-generation release, so really the target is better graphics. And, it felt like the big three were the right things to go after. Larger GPU, more advanced ray tracing, and the ML. Mm-hmm. So, not that complex.
Another subtle, polite shot. Stop trying to make it sound like astrophysics, bro. It's pretty simple. Does the game look and run better? Yes or no? All your numbers and stuff are irrelevant, Oliver. We love you and what you do over there. You heard I emphasize the you. I've heard you talk. You're not part of the problem. He never said Digital Foundry or Alice Bugaga was not part of the problem. He said, Oliver, you are not part of the problem. And we all know Oliver was geeked up. He was talking generational leap. Oh my God, I can't believe he's doing what he's doing. Then all of a sudden that died down and he started reporting on every itty bitty problem that Alex could find. Crazy, but we all peeped it.
Yeah, it's not that complex, but I think what we've seen so far, one really compelling thing, I think, is getting those fidelity modes, those 30 FPS modes, basically at 60 FPS with comparable image quality, very comparable looking visuals overall. So that is for sure something that is sticking out in this early batch as well as ray tracing enhancements like we're seeing in the Insomniac titles.
Yeah. Also personally speaking, it's been just great digging into the ML aspects of this and gaining some knowledge there. Because we know that's the future we're heading into. And so what an opportunity to gain all of that knowledge with the Pro, rather than waiting for the start of a true generation and having to get everything right with no experience whatsoever.
Yeah. One interesting thing about the PS5 Pro, it's obviously being upgraded in a ton of respects. You've got improved memory, improved storage, obviously a massively improved GPU, but the CPU is staying roughly the same as we had before. Now, there is a clock bump that developers can tap into there, but it is, broadly speaking, a very comparable CPU there. Why wasn't the CPU upgraded, and why was not such a big focus there?
It's really just a question of where you put your resources. And I wasn't seeing, and I didn't think I would see, that many titles that couldn't run at 60. That's kind of my litmus test. Yeah. I'm not asking, do all the games run at 120 at this point in time. I'm asking, do all the games run at 60? And you can count the AAA exceptions on one hand, I think, for games that didn't eventually run at 60. And so it seemed if we threw pretty much all of our resources into the graphics, that would be the best approach.
Right.
I'd say as a developer, the day Mark comes and says, hey, we want to give you guys a presentation about what we're thinking about for the next hardware, like that's a fun meeting for everyone. And we were very happy with where the focus was here, GPU-wise.
Shots fired again at not only the comparison guys, but also the devs. I never said 120. I basically said that this thing was going to do 4K at 60. What they sold us was a machine that would give us the fidelity of the PlayStation 5 with the performance mode all wrapped in one beautiful package. And that's what we got. In other words, that high frame rate mode that everybody wants to apply, the 120 hertz from inside the game menu, is diminishing your fidelity. You know it. If you've tested your game and you can't figure that out, you need to stop talking about this stuff, seriously. Like, it really makes no sense. As long as the 120 hertz is activated inside the PlayStation 5 menu and VRR is on, you're good. You don't have to turn it on inside the game menu. That's extra frames if that's what you would like to have. So when you compare these games, what was sold was 4K 60, not 120, as confirmed here by Mr. Cerny. Turn off the high frame rate mode Get all the bells and whistles, and you will be blown away.
Up to what are we doing with the CPU? What are we doing with the amount of memory? What are we doing with haptics? It's a whole new experience that the developers can go out. And I think it's really helpful, even if we drop words like revolution from the conversation, I think it's really helpful if the developers have that thing to consider and can ask the question, okay, this game, yes, it'll ship on one, it'll also ship on the next, but how can it be a different creature for each of those? Not gameplay-wise, but in terms of the visual experience.
I kind of had one other question about the hardware here. Given that the PS5 Pro seems to handle areas where RT is quite divergent a lot better than PS5, I know this generation so far we've not really seen games that use path tracing, possibly because of these fundamental issues here. Do you think that could be something that feeds into games that are using more advanced ray tracing techniques or even trying to ray trace all their lighting?
Well, I think we've already seen it. We've already seen that consistency of ray tracing performance pay off even in the Spider-Man 2 patch we've done. So we're able to put in ray traced AO. We have some ray traced shadows in there, and places where we were bumping up against those divergence limits. In fact, the water reflections in Spider-Man 2, we cheated them all so that they were less divergent than would be physically accurate in the water to sort of scrape that performance back. And so we're already seeing opportunities where it's paying off for us.
I think path tracing on PS5 Pro would be a little tricky to do, but you know, I wouldn't put it past the developers. There are some amazing engineers out there.
It sounds like a challenge.
Okay, great. And one final question here. What is your kind of vision for what developers will be achieving on PS5 Pro ultimately in the future? Like, what would you say in a couple years, you're looking at PS5 Pro software, what would you be happy with ultimately?
Yeah, I'm happy with the launch lineup, to be honest. Yeah, we view it very simply, is we're just making tools for the developers, and how the developers use those tools, that's up to them. And so, you know, we've seen a couple different ways of doing it, I think, right now. Part of the fun will be, you know, go up 3 or 5 years, there will be a lot more different ways to use them that we hadn't had anticipated. Just look forward to it.
So basically, he put all the devs on notice and all the haters on notice. PS5 Pro can do path tracing. It's just going to take some know-how and some engineering to get it done, and some smarts. Man, I've never seen someone so politely take care of probably like 4 groups of people at the same time. It's such a polite demeanor. Hats off to Mark Cerny for letting everybody have it that's been hating on the Pro, and saying what all the people in the comment sections have been saying that have one, how they love it, how amazing it is, how much better it looks. But maybe if I tell you like Digital Foundry, you'll understand a little better. So let me hit you with my AMSR voice and tell you all have a great gaming day. Get you a PS5 Pro. You won't be sorry. And enjoy gaming. Stop the hate. Stop the negativity. Let's love. Let's live. Let's game and be happy. Nah, but for real, your boy Old Man Gaming Guru out.